Hello, and welcome to our next lesson in Chemistry Foundations, where we will focus on atoms, elements, and compounds. We'll begin with the formation of compounds. We'll discuss how compounds form from elements through chemical reactions, and we'll take a first look at using chemical formulae to represent these reactions. Next, we'll look at the key characteristics of compounds. We will identify the key characteristics of compounds and the energy changes that occur during chemical reactions. We'll also touch on the fact that compounds cannot be separated into their constituent elements by physical means. Recognizing the difference between atoms and elements is crucial because the substances we are interested in as humans are not individual atoms, but rather huge collections of atoms, often from many different elements. For example, an average adult human body contains around 7 billion atoms from a huge number of different elements. By understanding how atoms combine with other atoms to form substances, we can better comprehend the vast array of materials we encounter in the natural and manufactured world. Let's begin. We know from previous lessons that an atom consists of three main particles: protons, neutrons, and electrons. Protons and neutrons are located in the nucleus, the center of the atom, while electrons surround the area outside the nucleus. Each type of atom is defined by the number of protons it has, which we call the atomic number. Now, what is an element? An element is a substance made up of only one type of atom. Remember that each type of atom is uniquely defined by its number of protons. For example, all atoms with one proton are hydrogen atoms, and the element hydrogen is a substance of any amount that consists only of hydrogen atoms, just like the term water refers to any amount of water. Elements like oxygen, carbon, and iron are all examples of substances made entirely of one type of atom. The periodic table is a way to organize and display elements based on their atomic number and properties. Next, we move to compounds. Compounds are formed when two or more different elements undergo a chemical reaction to form a new substance. In this instance, we have sodium and chloride atoms which undergo a chemical reaction. These two elements react, which involves the rearrangement of atoms to form sodium chloride. Importantly, the new substance that is produced is not an element, since it contains multiple types of atoms. In this chemical reaction, we have two different types of atoms. Therefore, we call sodium chloride a compound. For instance, when hydrogen atoms and oxygen atoms react, they form water, known as H2O, which is a compound. This reaction can be represented by the chemical equation 2H2 plus O2, which becomes 2H2O. The result is a compound, water, that has different properties from the individual elements, oxygen and hydrogen, that formed it. We will examine chemical equations in greater depth in a following lesson. Compounds always contain elements in a fixed ratio, determined by their chemical formula. For example, in water, H2O, the ratio of hydrogen to oxygen is always 2:1. This specificity in the ratio is crucial because it defines the compound's identity and properties. We are able to show this ratio using H2O. The subscript 2 indicates that there are 2 hydrogen atoms for every 1 oxygen atom. This concise way of showing the elements and their proportions make chemical formulae very useful. Compounds exhibit unique chemical and physical properties that are quite different from the properties of the elements they consist of. For example, hydrogen and oxygen are both gases at room temperature, but when they combine to form water, the result is a liquid. Energy changes also accompany chemical reactions. Some reactions release energy. These are called exothermic reactions, while others absorb energy. These are called endothermic reactions. This energy change can be observed as heat, light, or sound. For instance, when hydrogen reacts with oxygen to form water, energy is released in the form of heat and light. In a later unit, we will look at energy changes in much more depth. Finally, separating compounds into their constituent elements by physical means is not possible, meaning that we cannot separate them back into oxygen and hydrogen. They require a chemical reaction to break the bonds. For example, to separate water into hydrogen and oxygen, a process called electrolysis is used, which involves passing an electric current through the water. This is what electrolysis might look like in your textbook. And this is what it looks like in practicality. We'll explore bonding in great depth in a later unit. Today, we discussed how elements combine to form compounds through chemical reactions. These reactions involve the rearrangement of atoms to create substances with new properties. We also touched on representing compounds using chemical formulae, which are derived from the symbols of the elements involved. We'll take a closer look at chemical formulae in our next lesson. We also learned that compounds exhibit distinct properties from their constituent elements, involve energy changes during chemical reactions, exothermic or endothermic, and can only be separated into their elements through chemical reactions. See you next lesson.